Hello friends, I am Dr. N.B. Hulle from G.H. Raisoni Institute of Engineering and Technology, and in this video we will try to understand the architectures. But before going in detail of the architectures, just I will discuss what we have discussed in the previous lecture. In the last lecture, just I will go starting. We have discussed about the introduction, then elements of the VHDL language, that is how is the VHDL, features of the VHDL, concurrent language, sequential language, timing specification, simulation language, test language, design hierarchy, design libraries, its logic systems, then non-valued logic system, then elements of the VHDL programming, that is basic building blocks we have discussed. This point we have discussed the entity, and today we will discuss about the architectures. In this case we have discussed basic about the entity, then architecture, then configuration, and then packages, and we have discussed in detail rules for legal identifier, reserved words of the VHDL language, then entity declaration, examples of the entity declaration. Now we will discuss about the architectures. Architecture specifies behavior, function, and relationship between the inputs and outputs of the entity. Because indirectly it gives the working or functioning of the proposed module. It contains only the concurrent statements. And if we have to use, or if we are using the sequential statements, those sequential statements must be enclosed by the concurrent statement known as the process statement. I will discuss it later on. The design can be described in the architecture using various levels of the abstraction to facilitate faster design, better understanding, and less complexity. An entity can more than one architecture. Means entity can be one, but architectures may be more than one. And if our system has more than one architectures, in that particular case we have to use the configuration. There cannot be any architecture without entity. Means if there is an architecture, it must has the entity. Now we will discuss the syntax about the architecture. How is the syntax? The architecture starts with the reserved word architecture followed by the name of the architecture. This is user defined parameter, that is identifier. This of is a reserved word architecture followed by the name of the architecture of name of the entity for which entity this architecture is defined. Is declarations, then begin, concurrent statement, end, and name of the architecture. These are the declarations. All declaration except variable declaration must be before the beginning of the architecture. I repeat this sentence again and again, but it is important. I will discuss when I will go to the declarations. All the declarations except variable declaration, it should be before the beginning of the architecture. Now I will take some examples, and through these examples we will try to understand the syntax of the architecture through some modeling styles also. Here, architecture modeling styles. Architecture can be modeled in following four ways. The architecture modeling style may be behavioral, may be data flow, may be structural, or may be mixed. When to use which modeling, that depends on the data which is available with us or information of the system available with the design. Behavioral modeling is suitable whenever the truth table of the system is available with the design. Data flow modeling is suitable whenever the Boolean expressions or equations of the systems are available. Structural modeling. Whenever circuit diagram of the system or actual architecture of the system is available, in that case we will prefer the structural modeling. And when we are using the combination of any two, that modeling is known as a mixed modeling. If we are using the combination of maybe truth table, maybe Boolean expressions, or maybe the circuit diagram, then that modeling is known as a mixed modeling. Now, with the example of the half adder, I will try to explain how is the behavioral modeling, how is the data flow modeling, how is the structural modeling, and how is the mixed modeling. And through these examples of the HE half adder, we will also try to understand how to use the architecture within a system after the entity declaration. To begin with some basic points, we will consider half adder example to understand the different modeling style as I have mentioned. I will take the three things: truth table of the half adder, Boolean expressions of the half adder, and circuit diagram of the half adder. Then, using this truth table, I will implement its behavioral model. Using this Boolean expression, I will implement its data flow model. And using this circuit diagram, I will try to implement its structural model of the same circuit, which is nothing but the half adder. And then we are able to differentiate between all modeling styles which are available in the VHDL. To start with the first modeling style, which is the behavioral modeling style. Behavioral modeling style shows how our system performs according to the current input values. Behavioral modeling works on the sequential execution and it uses the truth table system to be implemented. Example. Before starting implementation of any system, here our plan is to implement the HA, that is half adder. We should write the black box. We should write the black box for that particular system. Means what? What number of the inputs or which inputs are available to the system and what are the outputs which we are planning to take from the system. Now this is the black box for the half adder. We have the two inputs A and B, and we have the two outputs, which is nothing but the sum and carry. Thus the black box generally help us to write its entity part. Here this part, entity declaration part. How? I will discuss. Before that, we will try to understand the truth table. This is 0 and 0, its sum is 0 and carry 0. 0, 1, its sum is 1 and carry 0. For 1, 0, its sum is 1 and carry 0. For 1, 1, its sum is 0 and carry is the 1. This is the basic truth table available for the half adder. Right? Now, we will try to implement the same. I will first complete the entity declaration part from this black box. We have the two inputs A and B that I have defined. Entity, this is the reserved word, followed by the name of the entity. Name of the entity is HA, that is half adder. I have used HA. The name of the entity can be anything which is the legal identifier, and HA is a legal identifier. That's why I used the HA. Is port. Port declarations, we have A and B. This is one port A and B colon in std underscore logic. This is input declaration. Then we have the two output ports, sum and carry. This is sum comma carry. Its direction is out. Look at this direction, which is in and available in std underscore logic, followed by the bracket, followed by the semicolon, and end HA. This part is the entity declaration part. Is it right? Then after the entity declaration part, I will come to this architecture. How is the architecture? Architecture start with the reserved word architecture followed by the name of the architecture. This is the name of the architecture. Name of the architecture can be anything, but to understand the other colleagues, we are mentioning it as behavioral, data flow, structural or mixed, whatever. This is the identifier. Architecture followed by the name of the architecture of, this is reserved word, and this is the name of the entity. Name of the entity is HA, that's why it is HA. Architecture followed by the name of the architecture of name of the entity is, and this is the beginning of the architecture. If there are any declarations, those declarations must be before this beginning of the architecture. For this system, there is no declaration, that's why here is. And whenever we are using the behavioral modeling style, we have to use the process. Because in the behavioral modeling, we are using the sequential executions or sequential statements. And whenever we are using the sequential statement, we should use the process. Here, the process, and this is the process sensitivity list, means the inputs on which these outputs will depend. This is A comma B, begin. Now look at the truth table. This can be written in numerous ways, number of ways. I am using the if statement here. How is the if statement? I will discuss again later on. But here, begin of the architecture. If A is 0 and B is 0, look at here. If A is equal to 0 and B is equal to 0, here we have to use the single quote for the single value. Single quote, and B is equal to 0, then sum is assigned as 0 and carry is assigned as 0. Means here sum is assigned as 0, carry is assigned as 0. Else if. It is not the else and if. I will discuss it later on in detail. It is else and if. It is not like this. It is else if, ELSIF, else if. Means whenever we want to use else statement and if statement, the VHDL has this facility else if. Else if A is 0, B is 1. A is 0, B is 1, then the sum is 1 and carry 0. This is sum is 1 and carry 0. Else if again A is 1, B is 0. A is 1 and B is 0. Then sum is 1 and carry 0. This is sum is 1 and carry 0. Else, and the last clause should be the else. Else, sum is 1, sorry, A is 1, B is 1. In that case, this is else clause. The sum is 0 and carries 1. Sum is 0 and the carry is 1. And this is the end of the if statement. Here ends the if statements. This is the beginning of the process. It should be the end of the process. And this is the beginning of the architecture, and it should be the end of the architecture. This is the way to write the VHDL code whenever we are using the behavioral modeling style. In the similar way, the same example. The example is a half adder. For this half adder, we want to use the data flow modeling style. This modeling style, that is data flow modeling style. If we are using the data flow modeling style, in that case, it shows how data signals flow from the input to output, registers and components, and it works on the concurrent execution. With no process is required for any other modeling except the first modeling, that is behavioral. As well as in the mixed modeling style, if we are using the behavioral, in that case also again we have to use that process. Especially for data flow modeling style and structural modeling style, we don't require the process statement. In this case, first we should begin with the black box. Yes, already I have discussed that. This will help us to write the entity part. It will start with the reserved entity followed by the name of the entity, which is HA is port. Here AB are the input ports, AB colon in std underscore logic, and the sum and carry are the output ports, sum and carry out, followed by the bracket, followed by the semicolon, and HA. This is the entity declaration part. Then architecture. Architecture data flow, data underscore flow of HA is this is the name architecture followed by the name of the architecture of name of the entity is. This format or this standard syntax should be used. Architecture followed by the name of the architecture of name of the entity is. This is the syntax always. I will repeat once again. It should start with the reservoir architecture followed by the name of the architecture of name of the entity is. This procedure we have used, and here the name of the architecture is the data flow. Here is the begin of the architecture, and directly we will put these Boolean expressions. This is assignment operator used in the VHDL. Sum is assigned as A XOR B. This is A XOR B. XOR is a reserved word, but we are not defining it as an identifier. Sum is assigned as A XOR B, and this carry is defined as A and B. This is the VHDL code and name of the modeling, that is data flow, or name of the architecture to be exact. And this is the VHDL code for this type of the modeling, which is data flow modeling for the same architecture or same device, which is the half adder. Through this example, you might think that data flow modeling is simple, but not. It is not always true, because for some of the systems, Boolean expressions are more complicated, difficult to design. In such cases, it may be difficult. Now here I will come to the next modeling style, which is the structural modeling style. As I have mentioned previously, it uses the circuit diagram of the architecture or that particular module. Structural modeling style shows the graphical representation of the models, instances, components with their interconnections. In structural modeling style, we define how our components, registers, models are connected to each other by using nets or wires. Structural modeling works on the concurrent execution. This also works on the concurrent execution. For any architecture or for any system design, we should start with the black box. This is the black box. It will help again us to write the entity, which I have discussed in the previous two example. Entity followed by the name of the entity is port. These are the port, sum and carry, and then end of the HF. Then here, this is one declaration which is used in the structural modeling, which is known as a component declaration. And as I have mentioned previously, all the declarations except variable declaration should be before the begin of the architecture. Here is the begin of the architecture, and these are the declaration. It should be before the begin of the architecture. Component declaration. What is the syntax of the component declaration? Again, I will discuss component declaration in detail. Well, to discuss with the structural modeling, I have to use this model. That's why I have taken it directly. It is starting with the reserved component followed by the name of the component. Name of the component. We have the two components in the circuit. One is the XOR gate, another is the AND gate. Name of the entity cannot be XOR because the XOR is the reserved word. That's why the name of the entity I have given XOR underscore gate. This XOR underscore gate is not the reserved word. Only XOR is the reserved word. That's why I'm using that. XOR underscore gate is. Here we have the two inputs I1, I2. Yes, I1, I2, two inputs. This is O1 is the output, O1 is the output, and AND component. This is one component we have defined. At the same time, we will define another component. This component is AND gate. Again, AND cannot be the name of this entity or identifier. That's why I have used the component AND underscore gate is port. We have I3, I4 and O2. I3, I4 are the inputs and O2 is the output. These are the declaration, that is component declaration. Now after that, we can start the architecture. It's starting with the reserved word architecture followed by the name of the architecture, which is structural, of the name of the entity, which is HA is. See, start with the reserved architecture followed by the name of the architecture of name of the entity is. Then here is the begin of the architecture, and here we are using the component initialization. And in the component initialization, the sequence of the ports in the component declaration has a lot of importance. How is that? I will make the connection first for this module 1. This is, I will name it as M1. This is identifier M1. This identifier can be anything. Module 1, M1, M2, or maybe the half adder 1, half adder 2, or component of the half adder. It can be anything which is legal identifier. This is M1 followed by the colon followed by name of the component. What is this component? This component is the XOR gate. That is XOR underscore gate. XOR underscore gate. XOR underscore gate. Then here is a port map. This is reserved word again, port map. Followed by the bracket, and in bracket we are connecting the external terminals to this XOR gate. Look at here. This I1, I2, I3 and O1, these are the terminals of the XOR gate. To this I1 we are connecting A, to this I2 we are connecting B, and to this O1 we are connecting sum. How is the sequence? I1 is the first, this is second, and this is third. Means whatever we will write first here, it will be connected to the I1. Means this A is connected to the I1. Whatever we will write the second, because here only 3 pins are there, or 3 points are there. First whatever we will write connected to the I1, second whatever we will write connected to the I2, and third terminal will be connected to the O1, which is the sum. Means these connections 1, 2, 3, these 3 connections done. Similarly, for module 2, this is M2 followed by the colon followed by the name of the component, and name of the component, this component is AND gate, that is which is defined here, AND underscore gate. What we want to connect to the I3? I3 we want to connect A, means here should be the A first. What is the second? I4. What you want to connect to the I4? B. It is comma B. And which parameter we want to connect to the third terminal, which is the O2, that is carry, that is comma carry followed by the close bracket followed by the semicolon. Means here this part, means structural modeling has 2 basic things. One is known as the component declaration and another is known as a component initialization. This is initialization of the first component and this is the initialization of the second component. This is the third modeling style, which is the structural modeling style. And finally I will come to the last modeling style of this architecture, which is nothing but the mixed modeling style. Means for the same hardware, which is the half adder, we have discussed behavioral modeling, we have discussed data flow modeling, we have discussed the structural modeling. Now we will try to use, or we will try to implement is mixed modeling. Means we are using this Boolean expression and we are using this circuit diagram. Means I am planning to use both structural modeling and data flow modeling together. You can use the structural or behavioral, data flow or behavioral or any other combinations also. Now I will define first its entity, which is the same entity followed by the name of the entity is, then port, its port declaration, input port declaration, output port declaration, then here it is the end of the entity. Then I am using the structural modeling, and in the structural modeling I am defining this XOR gate. Component XOR underscore gate is port I1 I2 in std logic O1 out std logic end component. This part I am planning to design by using structural, and this part I am planning to design by using data flow modeling style. You can use behavioral modeling style also. Architecture mixed. How is the syntax? Start with the reserved architecture followed by the name of the architecture of name of the entity is. First module I will implement by using structural M1 followed by the colon followed by the name of the component, which is XOR. Port map. Here I1 I will write A, means I1 is connected to the A. I2, I will write B, means B is connected to the I2. This O1, I will write sum. This sum is connected to the O1, means this part will be implemented. Now, this carry, I am not using the structural modeling for this. I am using the data flow modeling for this. This carry is assigned as, I am using this Boolean expression, A and B. This carry is assigned as A and B. This is the component declaration for structural modeling. This is component initialization for structural modeling. This is the structural modeling. And finally, I am using this part for data flow modeling, and I am using structural as well as data flow modeling. That's why this modeling is known as a mixed modeling. That's it about the basic part or basic regarding the architecture. And through this video, you may be or you might be able to understand behavioral modeling style of the architecture, data flow modeling style of the architecture, structural modeling style of the architecture, or maybe the combination of all, which is mixed modeling style of the architecture. Thank you. That's all for this particular video.